Sorry guys, a call came in and wrecked our video. So now we're starting on our second video with number 5. And that is 8k to the negative 5th times 2k to the 3rd over 4k to the negative 6th. Okay, so you look at this and there's no exponents that you have to distribute. So I would probably address this by first just multiplying the numerator to make it one thing. So when you go to multiply the numerator, 8 and 2 are coefficients, not exponents, so they actually multiply and make the number 16. Now, k to the negative 5th and k to the 3rd are the same base, so you add the powers. So you're going to have k to the negative 5 plus 3 over 4k to the negative 6th. Now, negative 5 plus 3 is negative 2, so this becomes 16 k to the negative 2nd over 4k to the negative 6th. I noticed some mistakes with this question on your guys' homework. The only things that have the negative powers are the k's. The 16 and the 4, they don't have a negative power with them, so they stay right where they are. The k to the negative 2nd has to move down, and the k to the negative 6th has to move up. So what you end up with after making those two movements is you end up with 16 k to the 6th over 4 k to the 2nd. So the 16 and the 4 are the same place. Now those are coefficients, so they can actually divide or reduce. 16 over 4 reduces to 4 over 1. So now you have 4 k to the 6th over 1 k to the 2nd. And now you notice you have dividing k's. When you have dividing k's, you subtract the exponents and you end up with 4k to the 4th. And that is number 5. Moving on to number 7. Number 7, we have, oh, you guys made a funny mistake on this one. It's 6L m to the 2nd. You guys read it as 61, a lot of you. So let's just make sure we realize it is 6L m to the 2nd over 3L m to the 6th, all raised to the 2nd power. Now, the way this question is set up, oh, L to the 3rd, sorry guys. The way this question is set up, you can decide to reduce first and then distribute the power, or distribute the power first and reduce second. I noticed on a lot of your guys' homework that you like to reduce first, so I'm going to do it that way. If you reduce first, you have the 6 over 3, which are regular coefficients, which would make 2 over 1. You have dividing L's, which means you subtract the powers. Now notice that L to the 3rd is in the denominator. That's where the bigger power is. So your L is going to be L to the 3 minus 1 in the denominator. And then you have dividing M's. So when you have your dividing M's, you're going to subtract the exponents as well, but your larger exponents in the denominator again. So you're going to have m to the 6 minus 2 in the denominator. And that's all still being raised to the 2nd power. So now what you have, just in a little bit of simplifying, is 2 over L to the 2nd, m to the 4th, all raised to the 2nd power. Now since you hadn't distributed it yet, you would distribute it now. So you're going to have 2 to the 2nd over L to the 2nd, m to the 4th to the 2nd. 2 to the 2nd is not an exponent, so you have to actually just do 2 times 2, which makes 4, double powers multiply, so you get L to the 4th, M to the 8th, and that is number 7. Number 9. Number 9 looks intimidating, but we're not going to let that bother us. U to the negative 3rd, V to the 5th, times 9U to the negative 5th, V to the 2nd, over 3U to the 6th, V to the sorry guys, negative 8th. Okay, there's no exponents to distribute, so you have to decide. There's a couple of different things you can do from here. One, you can move the negative exponents to the proper side of the fraction bar and go from there. Or you can make this into one item and then move the negative exponents. I think I'm going to move the negative exponents first this time. So that means this is actually over 1. So the U to the negative 3rd is going to move down. The U to the negative 5th is going to move down. And the V to the negative 8th is going to move up. So now you have V to the 5th over U to the 3rd times 9 V to the 2nd, V to the 8th, over 3 U to the 6th, U to the 5th. Take a second to absorb that. That's just moving everything to its appropriate location because of the negative exponent. Now, this is a multiplication problem. When you multiply straight across the top and straight across the bottom. When you multiply straight across the top, you have 3 V's being multiplied. That means you're going to have 3 V's being added. So you've got 9V to the 5 plus 2 plus 8 over 3. Again, now you have 3 U's being multiplied, so you're going to have 3 U exponents being added. U to the 3 plus 6 plus 5. So that gives you 9V to the 15th over 3U to the 14th. And then the last thing is that these coefficients are reducible to be 3 over 1. So your answer is 3V to the 15th over U to the 14th. And that's number 9. We still have 11, 13, and 15. What's wrong?
1.
Where's the 1? Oh, that one? You want that one there? Okay, so it is 3 over 1, but you don't have to put the 1 there because it's in the denominator. Three more.